Welcome to Easy Math TV. This is another video in our business math series, and we're going to continue talking about exponential models and exponential patterns. Uh, today's tutorial is specifically going to go over differences in words. Like, so when you see a word problem, how do you know that you're talking about exponential growth versus linear growth? Because in both situations, you can talk about the rate of growth. The rate of growth can apply in a linear situation, and the rate of growth can apply in an exponential situation. But how do you know the difference? And how do you calculate those differences? Okay, so we're going to go over that today. So when the the defining statement that we need here is when the growth rate is a number. So I want you to notice that right here. When the growth rate is a number, it's given to you as a number, then we are going to have a linear pattern. When the growth rate is a percent, alternatively, then we're going to have an exponential pattern. So that is the fundamental difference between linear pattern of growth and an exponential pattern of growth. When it's given to you in a word problem, you're going to see the difference is that the rate of growth is given to you as just a fixed number, or it's given to you as a percent. Okay, when the growth rate is a percent per year or per time period, you're definitely going to have an exponential pattern there, and we're going to see that play out right here. So we have two examples here that we're going to look at. The first example states the school population grew by, and let's just say a rate of the school population grew by a rate of about 15 students per year for 5 years. So I want you to notice that the 15 students is a number. It's not a percent. So when we fill in our table, we are going to add 15 each time to our population. What are we adding in the second situation? So in the second situation, the county estimated that the deer population grew by about 2% each year for 5 years. So we're still going to be adding something, but before we do the addition, we have to multiply. So we have to take 2% of the population and then add that to the existing population. Right? Just think about the situation here. You're growing by 2% each year. So you are adding 2% of the population. And when you see 2% of the population, you're going to be multiplying. So 2% of the population means times or multiply, you know? So 2%, take your 2%, multiply or times it by the population, and add that to the existing population. So we'll see how that works out in our spreadsheet here. So let's assume that the starting population each time is about 1,000. I know that's a lot of deer. That's okay. So we have a school that has a population of 1,000, and we have a deer population of 1,000 starting out. You can start out with any number you want, really, because that's open to us. We just want to establish a pattern here. So let's look at our school first. At year 0, we're starting out at 1,000. So how do we calculate the next population? We take equals, and we're going to take our current population in C2 and just add 15 to that, because we're growing by 15 students. right? Equals C2 plus 15. So I can fill that down. And what I want you to notice is that every time we went to the next year, we increased our school population by our delta Y, which is 15 students. So delta Y is actually showing you your growth rate. The delta Y here is showing you your growth rate. That's the slope of our linear model. So delta Y is a constant, and delta X is a constant, which tells us that the Y values are linear over X over time. So let's look at our deer population growth. So the deer population is growing by 2% each year for 5 years. So this is how we calculate that in year 1. We take 2%, and you can actually type in the 2% and multiply it by the number in H2. So 2%, take 2% of H2 and then add that to H2. So 2% times H2 plus H2, and hit enter. And I'm just going to fill down. And you notice we're starting to get decimal values, which is fine. We don't want to round those at all. We want to keep them as they are, okay? But let's calculate our delta y's and then calculate delta y divided by y and see if we actually have an exponential model here. So the delta y's are equals, and then we're going to do h3 minus h2 here. So the current y value minus the previous y value, hit enter, and at least in that first year, the population went up by 20. But notice as we fill that number down, that is not constant. Delta y is not constant. So let's calculate delta y divided by y. That's going to equal I3 divided by H3. And fill that down. So if you want, we can actually change that to a percent so you actually see that when you do your delta y divided by y, that is going to tell you what your growth rate is. Delta y divided by y is your rate of growth in an exponential model. So it's growing exponentially, okay? It looks like the deer population is outpacing the student population, if this is the same county. But it's just, these are just examples to show you. Okay, so that is how you can set up your data, how you calculate the two kinds of growth. When, especially if you knew how much you started out with, you can actually calculate what the amounts are going to be for the next several years. In the next video, we're actually going to do some graphing of exponential models, but I wanted to show you specifically the difference between what is a linear pattern of growth versus an exponential pattern of growth in a word problem. Like, so how do you tell the difference in a word problem? All right. Like, subscribe, comment down below. Make sure that you share these videos with people if you think they'll find them useful, and I'll see you in the next video.